about today are right triangles and trigonometry. We're going to look at sine, cosine, and tangent. We've already been working on this in class from the start, so that's fine. I want to go over it from the beginning now. There's a corny story that I told the other class, and they really didn't get a laugh out of it. So you need to appease me and laugh at the end, like it's actually funny. Okay? And what it did for me when I was in school, I remember my class, Mr. Lyman, 8th grade, Algebra 1, and at the end of the year, he started talking about triangles and trig, and we talked about this. He kind of like gave us a jump start for geometry. Now, he told the story, and it really is lame and corny, and it really doesn't make sense, but it helped me remember the acronym SOHCAHTOA. Okay? Now, SOHCAHTOA, as you know, is the ratio of sine, cosine, and tangent using the words opposite, hypotenuse, using the words adjacent, hypotenuse, and opposite and adjacent. And you've probably seen these words already in class. So the story went as follows. And if you don't care, that's fine. If you haven't memorized, cool. But if it helps you, if there's any way to memorize, like that stupid hymn I sang before, where you probably didn't do much, but you might remember it later on, okay? So, here's how the story goes. So, as you know, SOHCAHTOA relates the opposite, the adjacent, and the hypotenuse legs of a triangle. So let's take a look at a triangle, please. Draw yourself a right triangle here. Let's call it triangle A, B, C. We'll give it a right angle. Okay? And now, with this right triangle, what I would like you to do is to identify and look at B. Okay, let's look at B. And let's say we're given this length is 3 and this length is 4. I'm going to do it just with numbers for now, but I'm going to talk about variables more tomorrow, but I want you to see what numbers first so we're all clear. Okay? If I was looking at angle B, and I wanted to figure out its value, I need to start by identifying each of these legs with names. And my choices are adjacent, opposite, and hypotenuse. Which is the hypotenuse, and always which is the hypotenuse? The longest leg or the one opposite the right angle. Now, if I'm looking at angle B, is this opposite angle B, or is this opposite angle B?
4.
The 4, because you have to go opposite in the triangle. So let's call the 4 opposite. And again, this is with respect to angle B only. And then 3 becomes adjacent. What does adjacent mean in English? Next to. It's next to B, adjacent. Okay. Now, given that information, we have opposite, which is 4, and adjacent, which is 3. What do we not have? We could find it if we wanted. What is it? Because it's a 3, 4, 5 right triangle. For the sake of this, let's say we don't have it. Okay? So that rules out which of the operations of trig that involve. Yeah. They're out. How come? They both involve h, or hypotenuse. So you know right away it's going to be tangent. Next. You start by writing the ratio of opposite over adjacent. What is that?
4.
And we said that's what tangent is, right?
Yeah.
Now, what angle is it? Angle.
B.
So that's what my equation looks like from what we just did. The 4 over the 3 is opposite over adjacent, and the tangent is of that angle. Now, the next part is really weird, and it is not by any means mathematically correct, what I'm going to say. But I want you to think of it this way because it might help you remember, okay? If you had this equation on the top right of the screen, how would you solve for x?
Is that 5?
Divide by 5. So, if you were to say in this part you want to solve for b, think about dividing by tan. You're not dividing by tan. You're not, but think about that, okay? Next. What is the definition of division? The definition of division, Nick?
Multiplication by reciprocal.
Multiplication by the reciprocal. What's another word for reciprocal? Inverse. So, on your calculator, isn't there a tan to the -1 button? If you press second tan, that's what the inverse tan is. So if it helps you remember to do the inverse, because you're not really dividing, but it's like you are, but you're not dividing. Press second tan, and press 4 divided by 3.
Our section is
because you're trying to get the angle by itself this time. With Miss Starks, you guys just use tan probably so far. We are trying. So if you're confused, then pay attention because it might help in math. When you want to find an angle, you always use second tan or second sine or second cosine whenever you're looking for the angle. So press second, tan, it's going to open a parentheses for you, and then press 4 divided by 3. Hit enter. You should get 53 point something. If you didn't, you're in the wrong mode. You might have to go to mode and change your mode on your calculator. Make sure that your mode is on degree and not radian. Okay, 53 point?
13010235.
Unit? Nearest degree?
Degree.
Degree is the units.
Yeah.
Degree is the units, people.
So we don't.
Okay? That's how you find the angle. So you should be clear on that from class with Miss Starks. Now, just to make you appreciate your calculator, here's how you can appreciate a calculator a lot. When I started in high school, there were no calculators. I know. You wouldn't think that would be so long ago, but it wasn't that far long ago, right? So, you said there was an episode of this on Seinfeld?
No, he said you had to be smart. Wait, what?
Oh, I think you said Seinfeld. So, nothing. Sine value. This is Seinfeld. So, what I used to have to do is this. You used to have to find out whatever the ratio is. So what's 4 divided by 3? Check on your calculator. 4 divided by 3.
1.33.
Alright. Then you would have to use what's called the trig table. And a trig table would look like this. A trig table would have a bunch of numbers. Oops. Okay? Okay, this would be whatever this was here, the inverse, and it would say something like this. Okay? And what you would do is you would find the function and find that value. Where is 1.33333? It's between these, isn't it?
Yeah.
So what you would have is something like this. This would probably be like maybe something like that. And you would have to say, well, the value we were looking for is somewhere between here. So the angle, was it 53?
Yeah.
Sorry. You get the idea, right? So you'd have to what's called interpolate the data. You'd have to say, let me find that fraction, go to the tan column, figure out which degree it is, something in between, and it's around 53 degrees. Your calculator uses built-in functions to do this for you. But this is what you used to do. And I'll bring in a book so you can see what it looks like, just so you appreciate your calculator.
We'll never have to do this.
Never. But I want you to, just like before I talked about with that Newton method with the tangent lines and stuff, to find those roots or those x-intercepts, same thing, okay? You're going to use some sort of an algorithm in your calculator, but it happens instantaneously. All right? Anyhow, that was a side note from me. Let's move on. What I'm going to draw. Stay with me. Stay with me. Draw a wall like this on the right side. That's the wall of the room. Next, draw a force acting at some angle on the wall. Draw a dot where the force begins to show that it's like a ray. We're going to use the word vector, but let's say for now it's a ray. Draw an x and y axis that go through the origin at the dot. And make it dashed in your mind. Eventually you're going to do this all in your head. You're not going to have to draw all this stuff out, like the x and y axis. Next. You've heard of the word theta. Theta is spelled Theta. I thought for 4 years in math it was called feta, like feta cheese. And I realized that on the June regents of junior year of high school, after learning it this way for 4 years, that it was theta and not theta. Really stupid on my part, I know. So, it's called theta. It looks like this. Okay, it is not this symbol. That is an empty set or no solution. It is the first one. Okay, it is not the second one. It is not that symbol. It's theta. But did you think of it as theta? Yeah. So I thought I'd correct it now in case anyone else did what I did in high school. My teacher pointed it out to me, actually. So, at this point in time, theta is always an angle measurement. Theta in physics is the angle here. Okay, whoops. Angle here. Okay? So write this in words. Theta is the angle between the x-axis and the vector. Theta is the angle between the x-axis and the vector. Now, here's what I want to make a point of. We've talked about vectors already, whether you realize it or not. We said displacement was a vector, but distance was not. We said that velocity was a vector, but speed was not. So what was the difference? Does anybody remember between a vector and a non-vector, which in a minute we'll call a scalar?
Okay, so like that vector is only has an arrow pointing only one way. So I guess a non-vector would be going two ways.
No, is it the opposite?
Wait, sorry,
Vector has negative and positive.
repeat the question.
I'm going to go over the answer because we're running out of time and you should listen the first time. Normally I would, Mike, but we need to keep going. A vector from class, we mentioned, has some sort of value and a direction to it. For example, displacement could be 5 meters or it could be negative 5 meters. The negative or the positive indicates the direction. Velocity positive means to the right. Velocity negative means to the left. That's a vector. What about speed though? Speed didn't matter which direction. Distance, it doesn't matter which direction. It's just a number, 5 meters. So a vector has a magnitude and direction. Magnitude, M-A-G, and direction. Okay, a scalar has just a magnitude. Speed, distance traveled, those are scalar quantities. Because if I said to you, how far did you go from home to school? You might say, well, I walked up 5 blocks this way, 2 over, and 7 more. So that's a total of 14 blocks. But your displacement, remember, is directly from A to B. It's not taking the path. So distance and speed are scalar quantities because I don't care the direction you took. But a vector, S-C-A-L-A-R. But a vector, it does matter the direction. So in trig, you use angles. In this class, we're going to use angles. Here's your example of why this is important. Every time you do something in life, it's going to be at an angle. People think that a lot of things are flat. Most things are at angles, whether you realize it or not. For example, if you're pulling your little brother or sister in like a wagon at the park, that little cord is at an angle, isn't it? So even though you're pulling them this way, you're pulling up and out. If you were leaning against the wall, just casually, you might say I'm leaning horizontally. But really, look at my arm. Isn't it at an angle? There's an angle right here. Here's the horizontal x-axis. Here's the negative angle. If I were to be pushing down, here's the angle. Here's the x-axis here. Here's the angle here. So everything is at an angle. So we need to break them up into their components. So if I wanted to hold this eraser against the wall, okay, because it's so light, I can just apply a very light force against the wall and friction helps me. But if it were really heavy, I'd probably hold it like this, right? Push up on it also and hold it up. Or if I wanted to move this desk, I might lift above the ground first. Why would I do that? What does that help me with? Reduce the... So you end up pulling at an angle. And pull it at an angle. Everything's at an angle. So we have to start looking at vectors. And in chapter 3, we talk about projectiles. And they're launched. So they're launched. Imagine you kick a football. Does that go horizontal usually?
No.
Which way does it go? Diagonal, or horizontal and vertical. Right? Follow the path of the vector on the board. It will make a parabola over time. If it lands, if it were a projectile. So in section 3.3, we're going to be talking about this. We're going to be talking about projectiles at angles. So we're going to go into vectors. For now, this is where I left off in the other class. Okay? So a vector has a number like 3.5 meters per second, but has a direction at an angle of 30 degrees. And we're going to break it into components, and look at the y direction, look at the x direction, and put it all back together. Hold on, Scott has his hand up first.
Yeah, so this is just like a general,
Guys,
this is
Scott.
like a general introduction
Yes.
to velocities.
Yeah, tomorrow we're going to talk more about how this is going to apply to what we're learning with velocities and vectors, and forces and vectors, and then we'll move on to section 3.3, which is projectile motion. That's like our longest section of the year. Probably spend a good amount of days on that section. Okay? Camila.
So vectors, displacement, and velocity are vectors.
Vector is, good examples of vectors are displacement and velocity. Good examples of scalars are distance and speed.
What do you mean by magnitude?
Magnitude is the quantity. So Mike, if you were running at 7 meters per second, the magnitude is 7 meters per second. And then if it said east, the direction is east.
Oh, okay.
Okay? So I'll give you an example belowhand so you can see. Yes, Ev.
Did studying physics ruin action? I read online that
Everything's unrealistic, yeah. For sure.
so
Ruin what for you?
I mean, whatever, I'm not...
motion and you watch the angle of everything and you figure out
Yeah.
What did you say? I wanted to ruin what?
action movies.
So 35 newtons, that's a force, newtons, at 25 degrees southeast. Okay, so the magnitude is this, the direction is this. If you only have the magnitude, it becomes what's called a scalar. 35 newtons by itself is a scalar. With the direction, it's a magnitude, n for newtons.
So 3 meters would be the magnitude.
Southeast, 35 at.
So like if you were just giving 3 meters, it would be the magnitude.
That's why displacement, we have a tendency to say positive or negative. Because it's really east or west, north or south. You're giving a direction when you give a positive or negative. Okay? I will pick up with this tomorrow.